Hi. Um, Today is going to take up a very general topic, and a lot of people, the first time that they talk to us about different aspects, such as what is machine learning, what is AI, and what is data science. This is a very confusing set of definitions, and many of the times it's very confusing when you're talking to customers, especially people who know and understand business, but are relatively new to these terms. So I'll try to do it at a broad level. So we'll use the few of the concepts this time. First is machine learning. Or as people call it as ML. Then let's talk about artificial intelligence. And on the other hand, we have what we can call it as data science. And there's a new topic such as what we would cover, something that is deep learning. So historically, one of the oldest fields that are there is surprisingly artificial intelligence. Although it looks like something that's cutting edge, actually one of the oldest fields is artificial intelligence. So it has been around since the 1930s or 1940s, when people started doing computing through mechanism. This was even before semiconductors came into picture. And one of the important things, as the holy grail of what human beings want to do with technology, is to invent or come up with some kind of artificial being or an artificial entity which can do some of the hard tasks that we struggle in our day-to-day lives. So things that human beings can do largely by themselves and probably need to be trained to do, but when machines are able to do the same things, then they are called artificial intelligence. And artificial intelligence is often very closely related to robotics. And while a lot of this is common, and there is a lot of overlap between these two things, robotics is specific to what human beings can do physically, and artificial intelligence is specific to what human beings do with their mind or their brain. Many times it is artificial intelligence that drives robotics, but even without artificial intelligence, using sensors and mechanics, biomechanics, and other aspects, you can have robotics too. So things like in the industrial automation sector, you can have robotics without a lot of artificial intelligence, which is based on simple logic and simple mechanics. But in a lot of times, the modern robotics is driven by artificial intelligence, because you need a brain to tell the robot what to do and how to and how exactly to behave in a specific environment. So when we look at artificial intelligence, it is about things that human beings can do. For example, a simple concept is how human beings can look at a picture or look at a room and count how many people exist in the room. So this is a very human aspect, and almost every human, even when they're 5 years old, they can do this quite easily. But it is very difficult to create an entity such as a machine or a computer program which can do this very effectively. It's much tougher. So this has been, as I said, artificial intelligence has been the goal of human beings and technological developments to achieve an entity which is artificial intelligent. And most of the things that we attribute to artificial intelligence are things that people can do. So artificial intelligence also deals with signals that human beings can usually look and usually do, which means that it includes audio signals, it includes images and video signals, it includes other sensory signals such as brain scans, for example, in many of these cases. Now, a subset of the artificial intelligence is actually machine learning. So you can say that this is a parent, and a subset of this is machine learning. So machine learning is a specific way of solving artificial intelligence, which means that we have different ways in which we can create a machine that's intelligent. Out of all of these things, one of the ways is machine learning, which means that in machine learning, it is a set of algorithms where you can pass examples of how to do a specific task and train the machine to learn how to solve the task for a new signal or for a new example, which it has not seen before, and that is machine learning. And in the olden days, if you look at it in the 1950s, machine learning itself was not a very developed field, and a lot of the artificial intelligence used to be done through algorithms, through writing complex logical statements and trying to create an intelligence from the way people used to do programming. There was also a lot of attempts to do artificial intelligence through electronics, which means that you have a set of electronic circuits which can then achieve a specific target, and you can tune the system to reach a specific objective, which was used a lot in the early days of robotics too, and is used a lot in some of the industrial grade or robotic systems, where you can do artificial intelligence, which means you can do tasks that usually is done by human brain by writing a set of complex logic systems. But that is not done through a set of data points, which is done in machine learning. So you can have rule-driven artificial intelligence, but a narrower subset of what you can do with artificial intelligence is machine learning. So machine learning has been increasingly used as the most common method of artificial intelligence because of the availability of data nowadays, and also the processing power, which means that you can now process millions and millions of examples of how human beings actually do specific tasks, and learn from that and feed that to different algorithms which can learn from it and give you results as if it was a human being. Now, data science is an interesting field which has also been developed very much more recently. Data science by itself is more prevalent when we have had a lot of data. This could not have been something that was used by us when there wasn't a lot of data available for us to study. But interestingly, so data science is now considered as any of the techniques which is used when the data is complex and not the kind that we as human beings regularly see in our environments, which means that it does not include signals which is similar to an image, or similar to a video, or similar to an audio, but it includes other types of data, for example, like seismic data, or it could be data like a stock market, for example. So stock market data is not something that we see in everyday life. It's not something that normal human beings encounter. However, there is a set of numbers that we seeing over time, and trained human beings can predict something about these numbers. So a lot of data science actually and artificial intelligence, both of them use this very common machine learning techniques. So they use a set of algorithms which is used both by data science as well as artificial intelligence. The only difference between data science and artificial intelligence is the kind of signal that we're doing. So data science deals with any of the signals that we don't come across in day-to-day life, whereas artificial intelligence, by and large, requires the type of signals that we see in day-to-day life or as humans experience. Now, sometimes there is an overlap between artificial intelligence and data science. So, for example, you can see that temperatures, for example, right? So we experience heat, cold. We experience the temperature, but not in a very precise way, but in a very approximate way. So we know that if 2 days before have been hot, the third day is very likely to be hot, and we can sense seasons and things like that. So but at the same time, it is also a set of numbers which we can't look at the numbers and perceive anything very strongly in that. So is that a data science or artificial intelligence? It's sometimes difficult to classify them very neatly there. But broadly, things that we see, the kind of data or the kind of signals that we see in day-to-day life and are tasks that any normal human beings can do easily, is often considered as artificial intelligence, and which is like a human-like behavior, whereas data science is to deal with things that human beings don't normally encounter. Another distinction, minor distinction between artificial intelligence and data science is that in data science there is a sort of an interpretative aspect to it, which means that you have seen a lot of data, so you want to try and understand how this data is generated, which means that you want to try and analyze the source of this data, you want to try and fit it into a model and see if your theory about why this particular numbers look as they are, why have these numbers have been generated in this following way. So you can have theories about it. You want to understand whether your theory about it is correct or not. So there is a kind of an analysis aspect to it, which is there in data science, which is not as much as an artificial intelligence, which means that artificial intelligence is largely dealing with replacing complex human tasks or training machines to do complex human tasks that humans are really good at. So, and the last, topic that we'll be studying is deep learning. So deep learning is a further subset of machine learning. It's a very small subset of machine learning, which is a specific set of algorithms which use neural networks, and not just that it uses neural networks, they use a specific class of neural networks, which means that they are dealing with a very large set of connections that are made in these neural networks, and they are very extremely layered. So when we say deep learning, it is again a very small subset of the machine learning, and a smaller subset of artificial intelligence, and a small subset of data science. These are modern algorithms which have been possible for this. Algorithms themselves have been present for more than 30 to 40 years. But of late, because of the powerful explosion of computation that we are seeing all around, and usage of GPUs and the development of GPUs, we have seen that these deep neural networks that are there, or deep Bayesian networks, or things like that, which means that there is a multiple layers of information that we are stacking one after the other, and we do a complex set of computations, which are repeated computations, of course, but they are stacked, and there are several layers that are feeding onto each other, and that is called deep learning. And very often nowadays, people don't consider anything machine learning unless it is deep learning, which is wrong, of course. And many people do not consider something artificial intelligence if it is not machine learning or deep learning, which is again wrong, because there's a whole set of artificial intelligence that you can do which has nothing to do with machine learning, or which has aspects of machine learning, but can use very simple, not simple, but a different class of algorithms, which does not include machine learning, to achieve the same task. So this confusion is often prevalent amongst people who are new to this topic, but they hear this jargon everywhere. I hope that this particular session, or this particular small speech that I had, can help us understand a little better what the different terms mean. Thank you.